we have this one-dimensional finite element in here that we have this um, element with node I and node J. So let me just put it in here. These are the nodes I and node J, and this is the solution within the finite element, and the nodal values are phi sub I and phi sub J. So these are the nodal values. Now if we do this is just a little review. If we have this function as the solution between two elements, it follows that you could do that phi sub I in this case is equal to alpha 1 plus alpha 2 times x sub I, and then you will have that phi sub j is equal to alpha 1 plus alpha 2 x of j. Using this principle, we saw that we could actually produce the coefficients alpha 1 and alpha 2 and come up with an expression for phi. So you could say solving this, we obtain that alpha 1 was equal to phi sub I x of j minus phi sub j x of I divided by x of j minus x of 1, x of j minus x of I, and alpha 2 was phi sub j minus phi sub x, phi sub I divided by x of j minus x of x, x of I. If you substitute this into the equation, we came up with the main solution phi as being x of j minus x divided by the distance between the two. This is L over here, and then phi sub I plus the other one that is x minus x of I over L, and then phi sub j like this. Yeah. So in this particular case, we gave names to these things. We say this one here on the left, this is going to be called n sub I, this is going to be called n sub j, and these are going to be called shape functions. Okay, that's what it was. So if we look at this shape functions here, you will see that the function phi in this case becomes n sub I times phi sub I plus n sub j times phi sub 2, or in this case, excuse me, j, phi sub j. This is very significant because we have developed a situation where we have this the solution for one finite element, and what we're going to be doing today is expanding that solution to the others. This one here you could have in matrix notation something like this. You could have n sub I n sub j like this multiplies by phi sub I, and then phi sub j like this. Yeah? So, we solve it for one finite element. I think that there's nothing to stop us from saying the neighbor finite element is exactly like this too. So, if we look at this case in here, we know that these shape functions are weighting factors. In fact, it tells us what is the influence between those nodes, or what's the influence on the solution in the middle. What I would like to think of is, let me just give you a simple example that is to illustrate what the shape functions mean. Okay, let's say that you have, this is the finite element, and then you have two people at each end. Let's say here's one right there, and then you have another one over here like that, and you have a third person in the middle. He is together with he's tied up with a rope between them. So why don't we draw the rope like this? Let's say so to make sure that you understand. Okay, this fractions of the are proportional to the properties of the function. Like for example, on this n sub I think we made a little picture, but I think it might not be a bad idea to repeat here what the value is. This is 0. Let's take n sub I. Okay. What's the value of n sub I when x is equal to 0? This is equal to 1, see? And this is 0 at the other end. This is n sub I. And then when you look at n sub j, this one, when x is equal to when x is equal to 0, then this is 0, see? So, but when x is equal to x sub j, this is 1. So this is the n sub j. So what I'm trying to say is that in this example, if you have these two people pulling on this third that is tied up with the rope in the middle, the one that gets closer or pulls him closer, that we are going to call it the n sub I guy is this one in here, and this is the n sub j boy. Okay, so this, in this case, let's say A and B, the distance. If this one pulls it harder, the influence of this is measured by by the distance here, like this, see? In other words, that this node is 1, but at the other end is 0. Same thing with this other one. Let's say this pulls. The most important thing is this one. Yeah. So this shape functions, I am trying to explain the shape functions by using this little example of my own invention, that if he pulls him more here, B is going to be the measure of the influence. If this one here pulls him more towards this, then A is going to be the measure of influence. So it's a ratio, a percentage of the total, because you have the sum of both of these, yeah. So these are weighting factors. Weighting factors are percentages. Yeah. So what I'm trying to say is this n sub I and n sub j are very important and tells us which node influences more. Okay, having done this, we concluded that yes, you can do for one finite element, and now what we need to do is to do it for the rest of the elements. So in order to do that, let me go back to my presentation here. So this is the one finite element number 2, finite element number 3, finite element number 4. So in here you have, this is 1 with nodes 1 and 2, 2 with nodes 2 and 3, then 3 and 4, then 4 and 5.
Sir, can you speak up a little louder? We're having a hard time hearing you.
Okay. I'll try to do it this way. The other thing is we should hold on for a second.